okay if I submit my research topic now?
Yeah, definitely. Just do it by Sunday. So yeah, you can submit whenever you want to between now and then.
Can I choose
Do what? Oh yeah, it'd be good. Yeah, that's a good one. Yeah, it's a lot of information for him. That's for sure. Really interesting.
Did they do a movie on him?
Oh yeah, a couple. Yeah. Yep.
I've never seen him. I've heard a lot about him.
Yeah, in the I think in the top module of a class, there's one of them called Hacker Movies.
I've seen Hackers. That's a great movie.
Yeah.
Right.
Takedown is the name of the one about him.
Angelina Jolie's in Hackers.
Yep.
Two names for that. Let's say it's called Trackdown, but Takedown outside the United States.
Do what now?
They say that that movie has two titles or names.
Oh, okay.
It's called Trackdown United States, I think, and it's also known as Takedown outside.
Oh, that's weird. You can go and grab these handouts up here at the front. Yeah. Go and pick up those handouts out there on the end, the 2 handouts. No yawning. It's contagious. But I agree. Hello. You know, pick up the handouts there for you. Right there at the end. All right. Well, we're going to go get started. Thanks for those braving the cold. Appreciate you being here. Be by myself. All right. Got about four users online, looks like. So, all right, cool. All right. Well, tonight we're going to be doing Wireshark. And Wireshark basically is used in networking to debug a particular problem. The first handout I want to look at is the one that says at the top of it, download and install Wireshark. It's kind of a quick starter that you can use at home to get started with Wireshark. It says at the top of it, while debugging a particular problem, sometimes you have to analyze protocol traffic. And one of the things we learned in the first couple of weeks was the first thing hackers do is basically figure out what's on the network by doing some type of scan, right? Well, this type of program we're using tonight, Wireshark, is that program that does that. It scans networks for traffic and for certain protocols or certain, basically just traffic only. That's all it does. That's the whole purpose of it. So if there's an issue on your network, you can use this to debug it or find out where it's coming from, or like we're going to use tonight, just to play around and do ethical hacking and figure out what's on our network at any moment's notice, what the traffic is. It's a free program. It's been around for years. Wireshark has. You can download it at home from your Mac, Windows, or Linux computer. Hey, how you doing? You can pick up those 2 handouts right there. And so on your computers in front of you, you already have Wireshark. But before we do anything, I need everybody to go to week 3 lab and go ahead and submit your name, because you're going to take both these handouts home with you as always. I'm not going to collect anything from you. So to get to 50 points, make sure you submit your name in the week 3 lab. Those online, same thing. Go to week 3 lab and submit your name. I'll go there real quick to show you. So week 3 lab. And the 2 documents we're looking at right now, those that are online, we're looking at the getting started document, and we're going to be looking at the 3 Wireshark intro version 6.0. These are the 2 documents that the students in class are looking at right now. Okay. This podcast was a podcast done from last semester. I'm going to leave it in there. There's going to be different things I covered in there that I probably won't cover tonight. This link here goes you to the Wireshark website. I'll click on that. And basically this goes over all the different, from learning to downloading to going beyond. And so if you click on the learning module in there, which I'll do on the overhead if you want to watch, just watch it, has tons of learning modules. Like they add tons every week. User created, company created, anything you ever want to know about Wireshark, you can find on here, and it doesn't cost anything. So that's really nice. And you can learn a lot. And there's a lot of stuff you can do with Wireshark. Now, one of the yearly events you might look forward to in the future is SharkFest 19 is coming up. Unique name, right? SharkFest. Registration open for SharkFest, and you can go to that link. Let's see the dates here. It's going to be in Berkeley, California. If you've never been to California, Berkeley is a pretty area. And let's see here, just to see what the cost is. Blum, blum, blum. Let's see. Registration. Okay, here we go. Registration is now open. The conference is June 8th through 10th. Hunt Like a Shark pre-conference is June 8th through 10th, and pre-classes. And then the ShareFest conference is, SharkFest conference is June 10th through 13th. So they have some pre-conference stuff and then conference stuff. And it's going to be at UC Berkeley, at the actual UC Berkeley campus, which I've never been there. So know people that have. It's kind of a cool place, I've heard. So let's see here, registration costs, which I'm sure attendance is limited to 300. That's probably already sold out. So, attendance limited to 300. Let's see, or maybe not. Let's see, Shark only conference, $12.95 for Shark only conference early bird. So anyway, most students can't afford that, and teachers can't afford that. But anyway, if you have a windfall of money, it might be something cool to go to. But I think what's cool about this SharkFest, even if you can't go, which I've never been, is they do a lot of live streaming at the event, and everything's recorded. So if you can't go, which I've never been, like I said, you can benefit afterwards and during the event if you want to watch it, kind of like Apple does with their conferences. Everything's streamed. All right, so I'm surprised they don't have an option in here for like an Oculus, like going there with a virtual headset, like they're doing now for games and everything. Well, just an option. Anybody done that before yet? You done play? You go watch a basketball game or anything with the night, or went to a concert yet? I know people that have. It's pretty awesome. You actually get it. What they do in these concert halls is they set these cameras in front of the first row. So you're literally beyond the first row. You're in front, between the first row and the stage. And it's these cameras are set up. And so when you log in with your Nautilus to get to the event or concert, you physically walk through a virtual hall, sit down, and boom, when you look around, you're looking around as if you were sitting in that spot. It's pretty awesome. Yeah, it's pretty cool. Now, I think the cost is, not as expensive, but, I think sporting events are doing it now, if I'm not mistaken. And there's some concerts doing it. So you get a chance to do it, might be something fun to do. Okay, so Wireshark. I'm remoting in this lab to my Windows machine, just so it looks a lot like yours on your machine. So what we'll do first is fire up Wireshark on your computer. And so the easiest way to find it is if you hit the start button on your Windows computer, click on the start button, and then the little box there under where it says all programs, where it says search programs and files, just type the word wire in there, and you'll see Wireshark at the very top, and you can click on it, and it should be installed already for you on that machine. Once you click on it and open it, now you'll see mine. It's already been running for a while in here. And I'm going to go ahead and stop mine. So first thing you want to do is click on the capture menu and go to options. Now what it's going to do on options is, and this is in your initial handout, by the way, under number 2, the first handout under number 2 where it says go to options, capture options, which will display the following screen. Select the NIC card and enable promiscuous mode. Promiscuous mode doesn't mean you're going to get in trouble, by the way. It just means you're going to be able to see everything on your network, right? If you don't check promiscuous mode at home when you do this, those of you doing this from home, you're only going to see what's on your computer traffic only, right? So say your traffic is 192.168.1.10, you're only going to see the traffic for .10, that's it. You're not going to see traffic for anything else in your home or business. So by checking promiscuous mode, you get to see everybody's traffic. The other thing you want to make sure, and like in the computers in here, we have multiple NICs, a lot of times are enabled, so you might see multiple NICs in the list. You want to select the real NIC or the one that's connected in there. As soon as you click on the real world NIC in this class or at home, whatever your NIC card's called, might be called 3Com or Intel or whatever, you click on it, then you click the start button. Once you click the start button, it's going to start collecting data immediately. And I recommend expanding your screen to where you see that it fills up your entire computer screen. With that running, on the handout we just started going over, if you flip to page 2, the first page was on the download and install, number 1, select the interface and start capture, number 2. Flip to page number 3. There's a screenshot of kind of what you're seeing on your computer. So let's explain the makeup of the screen here real quick, of your interface. Okay, I've already showed you how to start it, right? Start a capture. Let's talk about the columns here on the capturing. You got number, time, source, destination, protocol, length, info. So number basically is just packets that are captured in succession from 0 to whatever, right? The time column is things that are captured on your network and when they're how long it took to capture it. So the first one on mine was 0.00000, which yours was as well. The next capture 2 was 0.004666, capture 3. So it's just succession of when it captured the next and that packet that it noticed on your NIC card. The third column is source, the source IP address of that packet. The third column, meaning where it came from. The destination is where it's going to. Protocol could be TCP, UDP, IP, ARP, DNS, just to name a few. Length is the length of the packet data. Info gives a little bit of information about that packet. And then you can click on each column. If you go by saying start with the source column, if you click on each column one by one, starting with source, it'll sort by that column, okay? And say you wanted to isolate an IP address while you're in here. It doesn't matter which one. If you click on the source column, and just select an IP address that starts with a 172.20. Doesn't matter what the IP is. Right click on that and then select apply as filter, selected. Apply as filter selected. What it's going to do now is isolate only that IP traffic for that IP address only. Now you'll notice in that IP traffic, and this is source only, by the way, .src. If we go up to the bar that says IP.src equals 172 to whatever you have in there, if you change src to ADDR, src to ADDR, and then hit return. Okay, what that's going to do is it's going to give an address anywhere in the capturing. It could be an address in the source or destination. In this case, it's only going to be the source because it's only one that it's capturing thus far. Let's say we want to isolate a certain protocol, like in mine, I have NBNS traffic, the name query traffic. Let's just say I want to isolate that one. At the end of that protocol, putting up that filter, I could put in 2 ampersands, the shift 7 key, 2 of them, 2 ampersands, and then I can put in the protocol in lowercase. I'm going to put in NB and S, and then hit return. Now I'm going to isolate not only that IP address, but I'm isolating that protocol. See? And so, as you can see, you can get really granular in your search. On the second page of the handout, under number 3, it says a source filter can be applied to restrict data traffic, as we've just mentioned. And there's actually 3 ways you can filter an IP. One is a source, like I mentioned, from the source column. The other is destination, which looks like this right here. It actually should be DST. That's destination column. And ADDR is just any column, source, or destination. The equals is going to be basically the does it equal to that IP address. Destination address number 4 with the page looks like that. And you can literally type it in, or you can right click on it like I showed you earlier and just apply that filter to that IP. And that's the simplest way to do it. It saves you from typing. Now let's say we just wanted to filter a protocol like number 5 says. So HTTP is a popular one, IP is a popular one. So let's start with IP. Just get rid of everything in that filter you have currently in there. Just delete everything. And just type in the letters IP lowercase and hit return. What we're going to get now is traffic, IP traffic, everything that we're searching, IP traffic. And if we search or click on the protocol column and go down, you'll see a whole bunch of TCPs in there, I'm guessing. That's IP. Because maybe if you remember or not, the first couple of weeks we talked about one of the major protocols within computer networking is TCP/IP. So IP is always going to be on the same protocol as TCP. All right, that makes sense? But it's easier to search for, and Wireshark has to search for by typing in the word IP. You might have saw some other protocols in there too. That's also piggybacked on IP, which is DHCP, DNS. Now let's go up to the IP and just type in DNS only. Now you're going to get a very limited amount on those, I'm guessing. I had looks like 8, right? And then let's do HTTP for that. Now what's cool about HTTP, and you're going to do a lab on that in just a second, you'll notice on the HTTP, you'll see some messages under the info column that actually make sense. You can actually read what it's talking about. What the HTTP one's doing is every time you go to a web page or some service on your computer does something through HTTP port 80, it's going to go into this column, HTTP. You'll notice on mine, it's probably on yours too, the RBC alert is fired many times, all the time. It's constantly alerting us for, or could be alerting us for things that may be campus alert, emergency alerts, whatever. So it's constantly being pushed to the network all the time. Now, if we were to isolate and let's say, I don't know, click on this X over here on the very right of your expressions, and then click on the expressions button to the very right, the expressions. Here's all the hundreds and hundreds and hundreds and hundreds and hundreds of field names that you can use. So we're not going to definitely go over all those. I'm going to go over the common ones that are used in filters. But as you can see, you can filter a lot of traffic. A lot of traffic can be filtered. The most common, and you hit cancel on that if you want to. The most common traffic to be filtered when you're searching for anomalies or issues is usually IP, HTTP, ARP, DNS, DHCP. So if I type in the letters ARP for ARP and hit enter, I will get a number of returns on that one. That's a popular one because what it's doing on the ARP table is constantly figuring out who is who. You'll notice it actually says in the info column, who is 172.20.0.1, who is 172.0.50, who is 172.0.49. And then it's tell whoever that's who they are. So what it's doing is constantly on the ARP tables on the server, and your computers are constantly figuring out who they are, where the servers are, what your IP addresses are, and MAC addresses, and putting it in a table, an ARP table. And one of the labs we do in here in a few weeks is the man in the middle, which poisons this ARP table. And you'll notice the destination on ARP is mainly always broadcast destination. Not to say it's not, there is anomalies in that when it isn't broadcasted. But for the main reason, what broadcast means is going to every machine connected to the network every millisecond, basically figuring out, kind of like the phone commercial, are you there? Are you there? Who are you? Are you there? Are you there? Who are you? Constantly doing that. And one of the way hackers get into networks and traffic is by poisoning this ARP table to poison the who is, to be, say, instead of the server being over here, the server is now on this computer with ARP poisoning. And you can do that with the right program, the right commands that you'll learn. So HTTP, we'll do that one again, or first time, I can't remember. If you type in HTTP, yeah, we did that one. Let's see, let's do the OR on number 6. You can do OR filters as well. So let's do HTTP and ARP, both, like it says on number 6. So it's HTTP, 2 bars, which is the key above the enter key usually, and then ARP, enter. On this one, you're going to get both ARP and HTTP traffic, both, or you should. Number 7, applying the AND condition. This helps to filter packets that match exactly with multiple conditions, or means one or the other. So if you flip the page to the last page, there's a OR statement, and you probably won't have that IP address on yours. So what I have you do is clear out your filter again at the top by hitting the X there. Click on the source column, and let's find an IP address, or let's click on destination column. Destination column, let's find an IP address in there. Doesn't matter which one it is right now. And we're going to right click on that destination column IP address, apply as filter selected. And now up on the address, we're going to finish up, we're going to reverse it. And the example on the last page, it says HTTP and IP.src. This one, we're going to just put HTTP on the end. So we'll do, at the end of that filter, I'll put and then HTTP. Now it's going to filter destination, and it's going to filter HTTP, destination, HTTP. Now, if I wanted to filter source, I could just change DST to SRC, hit enter. Now it's going to give the source IP address, as you can see, and on yours as well, and only HTTP traffic. Okay. Number 9, or number 8. Say we want to filter a port number. It can be done by using the filter TCP.port and then the port number. For example, tcp.port space 80. Okay, EQ 80. So go and type that in right into the browser, right into the bar there. It'll actually give you an example right at the top. So it should end up being like a tcp.port equals 80 is what it should be. And the page, it just says EQ, stands for equals. So tcp.port 80, let's do another port, like say maybe, I don't know, let's do like 110. That's for email. Probably gonna get anything on that. Let's do like port 25. Send SMP, probably gonna get anything on that. Let's do 443 for secure port. Got some on that. And that's probably gonna be for traffic that you've authenticated on, like maybe Eagle or yeah, Eagle possibly. You've authenticated onto the Eagle server from your IP address when you logged in tonight. That'd be an example of that. So, you know, list goes on and on of different ports that you can, port 21's a FTP port. More than likely, you're not going to have one, but I'm going to do it on mine just in case. If it is, I doubt it. If it's any traffic anyway on that, nah. And then I'll go back to port 80. Boom. And port 80 is going to be the #1 port because that's where all your web traffic is through. So that's the one you check a lot for anomalies and what's going on. Because normally, besides users browsing the web, and as you can see, it captures all the traffic on that computer, on that IP address for destination. And destination, the reason you want to do a local IP address on the destination is so you can determine what sites have been visited. Because the way it works on destination is if you go to RBC's website, it is the source, you are the destination. You click on a link, RBC is a source, you are the destination, right? Makes sense? And so when we're looking for traffic for individual people on a network, that's what we'll do. We'll search by the destination column and then figure in maybe port 80 to just look at all traffic on that computer. Does that make sense? And by the way, while it's doing everything we're doing here, what's nice about it is we can then, and I'll show you in a second, at the end of the search, it can run for hours. We can save this as a file and search for stuff after we've saved it, right? So it can run for 8 hours, 10 hours, an hour, 30 minutes, whatever. And you don't have to watch it. You can just let it run. And then you can do your filtering later. So if you don't want to filter it live, you can run it overnight, come back the next morning, save it, and then you can open up that save filter log from Wireshark to do your filtering post-session once it's been ran. Number 9, matching packets containing a particular sequence. And this would be like a certain TCP sequence to filter a certain byte sequence on maybe traffic that an individual had happen on their computer or anomalies. Reject packets based on source or destination. So like IP.destination is not equal to that IP address, meaning you can't find anything in that IP address range. So that's some examples. And I'm going to go ahead and show you here. If you hit the stop button, the little red button, the little red stop capturing, and then go up to the file menu and do a save as, notice at the bottom it has an option to save it. And so I'll put mine to the desktop and I'll just call this one test and click save. And then go back to the file menu and hit close. And then we'll pretend it's tomorrow. And I want to go through that saved log that I just did. I'm going to go to the file menu and I'm going to open up recent. It should have it in yours as well. Open recent, select that file. And now you have everything that's been searched in that entire session that you can filter. Does that make sense? Filter just like we did if you're doing it live, but it's post session. And on mine, let's see here, I captured, In total, 65,353 packets. Was captured in that session, and you could have more or less than that or whatever. One of the other things I'll mention while we're talking about this, because we're going to do it in lab in a second, is let's type in this filter HTTP, and let's click on any one of the rows that have a get statement in it. In the info column. Doesn't matter which one. We'll double click on it. Double click on any one of the columns that have a get statement in the info. Now, when you do, you'll notice it brings up that packet, isolates it. And the reason I captured the get statement is that's what we're going to do for the lab. This is where it determines what actually was downloaded from that browser onto that computer. And at the very top, where it says frame, this is actually breaking down the data packet and the time and how many was captured. Ethernet 2, you'll notice in here you should have destination, source, and what version of IP. It should be version 4, IPv4. Internet protocol is the next one down. Gives the source and destination IP address. Also gives different flags, time to live, TCP protocol, header packet, source destination. Collapse that one. And now TCP protocol gives me the source port, the destination port. My source port was 2252, destination port 80. Then below that gives me more information as far as sequencing and things of that nature. Then lastly, the HTTP, the Hypertext Transfer Protocol. If you expand that one, this is actually the get statement for that web page when it was downloaded from Rock Valley College. A host, it says, is notified.rockvalleycollege.edu. And you'll notice all it does is see if it's connected, then it closes. See if it's connected, then it closes. See if it's connected, then it closes. That's all it does. It just makes sure that service is ongoing. The other thing you'll notice, if you keep expanding the get line, if you keep expanding, you'll get to a section where it says what info that get statement, what category that get statement is. In mine, the category is chat category. Severity level chat is how it categorizes that download. It also gives in full the HTTP request at the bottom. And then at the very bottom of the page, you'll see the hexadecimal version of what we just viewed on the left. And on the right is the ASCII of that hexadecimal, okay, which basically breaks down that HTTP get statement. All right, so that's helping getting started, the first handout. The second handout, I'm going to have you go through on your own, since I've kind of helped you with the getting started. This handout is going to walk you through basically a little bit more about Wireshark, and really where the lab starts is on page 2. It talks about going to a certain website. The website is a longer website. Let me see here. In fact, I'm going all over all the pages, by the way. We've went over some of these already, so I think I might just have you do the test run here. Yeah, let's do that. Let's start on page 3. Or page 5, I think it is. 1, 2, 3, 4, 5. Page 5 where it says taking Wireshark for a test run. Is that page 5? Yeah. All right, so the best way to learn any piece of new software is to try it out. Assume your computer's connected to the internet. You went through the getting started already. So basically, it goes through and says, do the following. Start up your favorite web browser and display your favorite web page for your home page. Start up Wireshark. You'll initially see a window, yada, yada. You went over all that already. Number 3, how to start it. You've done that. Number 4 goes over the different interfaces. You've done that. On number 6, this is where it has you get to, after you've stopped Wireshark and look at what your traffic has been on your computer, Number 6 is where it's a longer URL. I guess it's not terribly long, but you will have to type that in. Otherwise, you can probably go to the PDF in the lab, which I'll show you on the overhead which one it is, and you can click on the link if you want. It's this 3 Wireshark intro version 6.0 PDF. Somewhere in there, you're going on number 6. You should be able to click on that, or at least highlight it and paste it into your browser. Because what that's going to do is you're going to basically, after you click that link, you're going to break apart that packet and the get statement. So, all right, so go ahead and go forth and start with that number 1 on taking Wireshark for a test run. I think you have all the way number 10, where you exit Wireshark, and then you'll exit Wireshark, and then we'll talk about what you just did. For those online, we're doing the taking Wireshark for a test run. If you've not yet downloaded Wireshark, you'll need to do that. Wireshark.org, and you will go here to download Wireshark. Right there. And you'll notice there's options for 64-bit, 32-bit Windows, Mac OS. Either one. And one of the things, too, you might want to do while you guys are doing this lab is determine what your IP address is on your computer. And a couple ways you can do it. The easiest way to do it is if you hit the start button on your Windows computer and then just type in the letters CMD, hit enter, and then just do an IP config, IPCONFIG, and it should give you your Ethernet adapter real world NIC where it says IP version 4 address. So that command is CMD, and then IP config, and you want to look for the real world NIC at the very top, which gives you your IPv4 address. That's your IP address. And you should see that as when you start Wireshark, and you can search for it like we've showed you. Do I know? No, no, no. If you get done quick, which you probably will, you can go to, start searching websites on your computer to see if what Wireshark captures that as. Like I went to YouTube just to start playing a video just to see what it's capturing from my IP address. You try and find that link.
Oh, I found the link where it says to do the drop down and click capture or interface.
Yeah, you've already done that. If you go to the capture menu on Wireshark,
Yeah.
And just go, this is a different version on the computer on the handout. It's going to be a different version. That's why I went over that first part first.
Okay.
I've already showed you how to do the capture part, so that version is going to be a little different than what we went over probably. The Wireshark version. You'll capture like I showed you how to capture. Yeah. They changed the screens around a little bit, which that happens. Okay, let's go ahead and stop what you're doing here and go over your search of that website on number 6, which was the intro Wireshark file. Then I had you look at the get statement, I believe, of that file, break apart that packet, the protocol column for HTTP. And then once you broke it apart on number 9, you saw the packet in full. And I'll go ahead and click on mine as what you should have seen. I'll start mine after I go there. Oh, wrong one. This one here. All right, so I'll click on that. It launched it in IE, and I'll run it a number of times. Let me cancel out the Wireshark. And every time you start it too, we didn't go over this, but it'll ask you, do you want to save the last session? You'll just continue without saving. And now I'm going to go back to this file that I know it's opened in. And I'm going to run it a number of times by hitting the F5 key on my keyboard. It'll run it a number of times, and I'll go back to Wireshark and stop the traffic. Do it HTTP. And there's all of the F5s you just saw me do. Multiple different refreshes. And so I'm going to go to any one of these gets here. And specifically the hypertext protocol. And it tells me, not only does it tell me the data, but notice it also says what browser you were in, the user agent that you were on at the time. I actually did mine from Windows, from Internet Explorer is where I did mine initially from. And then it also gives the language, which is English, HTTP, HTML, the root host of the domain, which was the umass.edu, and then the message that was accepted, which was the contents of that file. Now that's a user message. The next one is the 292 length HTTP. Gives the server IP or the server host of that message. But multiple get statements on mine because I did F5 100 times. And so, but it's the same content each one. So when you broke apart the packet, on the get statement, it went over the segment for TCP, datagram, IP datagram, Ethernet. We went over those earlier, where you can, break apart a packet as granular as you want to be in that packet, just by double clicking on whatever row that you want to break open. And then first you're going to apply a filter, and then find the traffic you want to isolate, and then break it apart. And then congratulations, you've completed your first Wireshark lab. Tons of other resources, by the way, in Wireshark I want to go over real quick. Let me show you some examples of stuff I've gotten together for you. That way you can do more of this for sure at home. So if you look on the overhead, and those watching online, you can watch. I'm going to shut some of my tabs here. So the link under 3 Wireshark Intro version 6, the filter examples link. This is from Wireshark's website. It goes over more examples on filtering. Anytime you see in an example the word EQ or the letters EQ, it just means equal symbol. That's what that is. Okay. The or is always going to be the 2 bars. The and is going to be the 2 ampersands. Make sense? And so just remember that when you're viewing this information. But what I recommend is when you go home, you can do some of these examples in your environment to see what kind of traffic you get back. Totally harmless to do in any environment, really. But I would recommend doing it at home. If you're going to do it at work, make sure you have the permission of the IT folks. If you're in IT already, you can give yourself permission. That makes sense. That way, just people know what you're doing. Again, there are tools out there that can capture when people are using tools like this to monitor a network. So it's a good idea to let your folks know there at work if you are not in IT, what you're doing. And then to go over all these, there are some gotchas on some things, some filters that match against multiple protocols that you could utilize. That's the first link called display filter. Then the experimental one. There's experimental d2cl.pdf. This one has some more labs you can do on Wireshark. And so part one goes over the environment, kind of a refresher of what we went over tonight. Part two goes over hands-on lab. A lot of these screens that you might see in any tutorial with Wireshark, you just upgraded the version. It might look different than what's on your version of Wireshark, which would be the newest and greatest. Just be aware of that. But you should be able to figure it out just fine. But the second one's it's a multi-page, 26-page document that goes over multiple labs, multiple comparisons of labs, multiple capturing of a lab or of a packet and breaking it apart. So just a resource for you. You don't have to do it, but I recommend it. It's a good resource. And then, as I mentioned, the first of class, this Wireshark.org link is an awesome resource of all different types of resources. So what do you guys think of Wireshark? Pretty easy to use, right? I mean, there's a lot to it. The more you use it, the more you'll feel at ease using it. It's not a hard tool to use. It's just a lot of stuff to learn. And so best way to learn is to play around with it. Use it at home as much as you can. Do as many labs as you can. That's giving you an option. The best place actually to go, not to say the ones I've given you aren't bad, but the Wireshark.org is the most you're gonna have the latest and greatest videos and tutorials that folks put together that are really good. So, all right. So make sure you've submitted your name in week 3 lab. Again, thanks for showing up tonight. And do me a favor before you leave. You don't have to shut your computers down because I'm 110 classes coming later. But if you could make sure and log off of anything you're logged in, that would be awesome. You can stay logged into Windows on your machine, by the way. Just log off of Eagle and all that good stuff. Sound good? Awesome. We'll stay warm out there, and it's supposed to get warmer by 40 by Monday or by Sunday. So, hey, short weather, right? Kind of crazy, right? Anybody any pipes freeze, by the way? Yeah, that's good. At your windows froze over, okay. Well, make sure if you don't already know this, you probably already do, but make sure and let your water drip a little bit during this type of weather, especially on outside walls that your bathroom's against or whatever, because pipes can freeze pretty easy, especially like the weather we had last night. So, all right, we'll be careful and stay warm. We're supposed to get a whole 2 inches of snow today. So, almost over for this week anyway. See you later. See you later.